This lecture will be about transmission media, physical layer and transmission media. So we studied briefly the layered model and TCP/IP and the OSI reference model. The physical layer is actually I think there is something. Okay, these slides are not belonging to this. Okay, so the physical layer is the first layer in the both models, in the OSI and the ISO in the TCP/IP reference model. The physical layer will be dealing with bits, as we studied before, and transmission media. So we'll send bits from the sender to the receiver through this transmission medium. The medium can be different media like cable, wireless, fiber, whatever it is. So if we go and see what are the classes of transmission media, we can categorize them to two broad topics. Guided means bits follow some path or guide, and unguided. Unguided is clear, it's wireless. You don't have any, the data can go any path, so there is no guide but guided, you have some media that the data go through. So the guided media, we can classify them into twisted pair, coaxial, and fiber optic. And the wireless, we have different also technologies. We have radio, microwave, and infrared. We'll be studying these media this lecture. So guided media, you know, the untwisted shield pair. So these are unshielded twisted pair. So this is twisted pair, and this is plastic cover. This is the LAN cable most widely used. So you have 4 twisted pairs. This is called unshielded because there is no shield, twisted pair. So these are twisted pairs. So twisted pair cables, we have of course different types. It's twisted pair. We have coaxial cables. This is the coaxial cable. So you have this shield on the inner part. This is called a coaxial cable. And we have fiber optic cables. So we study these media in this lecture. So the first type, we said the most common is twisted pair cable. So this is a twisted pair. A twisted pair, you have 2 wires twisted. So you see, like this is a twisted pair. You see how they are? Okay, so I'll ask a question, why you need to use twisted pair? Why you don't just use the cables without twisting? Why we use twisted pairs? I think you've studied this before, so I'll ask this question. If anyone can answer, I'd like to hear your answers. Okay, please send me your names in the chat in 2 minutes so that I store the So I'm still waiting for the answer. Why we use twisted pairs? Can anyone? What's the advantage of using a twisted pair cable?
Doctor, to reduce the electromagnetic waves?
Interference, very good. To reduce or eliminate, you cannot eliminate, of course, to reduce the interference, electromagnetic interference. Okay, another question. So how this interference happens? How does this interference happen? Send your names in the chat. I'll close it in 1 minute, less than 1 minute. So this is a cable. It carries current, okay? Is that right? So if there is current flowing in a cable, what that current will cause?
Noise.
You remember the
Current will be because of magnetic field.
very good. So there is a magnetic field that if the current flows this way, so you'll have this magnetic field around this cable. Okay? So this magnetic field can in turn do what in the other cable? You studied the transformer, so we have current. It will, when the current flows, it will create magnetic field, and there is another winding. So that magnetic field will induce another current in the other winding. So here is like, say, transformer. So when the current flows this cable, there is a magnetic field. This magnetic field will induce a current in the other cable. This is called crosstalk. So without these twists, the crosstalk would be very high. But using these twists will minimize these crosstalks. So the twists are to reduce the interference or the crosstalk between these cables. Okay, clear? Okay, I saved the chat, so you don't need to send any. Okay, so we know now why we need twisted pairs. So actually, sometimes you'll use unshielded twisted pair. So this is unshielded. This is only a plastic cover that surrounds the twisted pair just for protection. But sometimes we use shielded twisted pair. So what is the why is we use the shield? You studied that before. So we use a shield to eliminate or reduce the effect of external EMF and external noise. But the twist will eliminate the crosstalk between these cables. So this will reduce the external, this will reduce the crosstalk. Okay, so we mostly use these types of cables, which are of course copper. So this cable, if you see inside, Here is copper, this is plastic cover, and this is another plastic cover. So this is, actually you don't have only one pair, you have many pairs. This is one pair, twisted pair. So this is copper, this is plastic cover, and this is another plastic cover that houses them all in one cover. So we have normally 4 pairs in a LAN cable. So 1, 2, 3, 4, 8 wires, 4 pairs. Okay, and they are all twisted. You see, this is one twisted, this is another one, this another, this another one. They are housed in this cover. This is unshielded because you see there is no shield. It's just twisted pairs. This is the most widely used cable. It's cheap and it's easy, and it's good also. But we have also shielded twisted pair. You see, again we have twisted pairs. So this is copper, this is plastic cover. Why you need the colors? You see, they are color coded. We need colors to know the individual wires in both sides so that you can connect them properly. So this is pair. This pair, look, this is a shield, okay? This is a shield. And then there is another shield that shields all of them. So this shield, you see, will even reduce the crosstalk more than the twist. So this shield can, because these 2 pairs will not do crosstalk like before when they are not shielded. So the crosstalk will be even less with the shielded twisted pair. Okay, and this is like a braid. So this is copper mostly, or can be sometimes aluminium, and this is normally aluminium foil. They use it because it's cheap and light. So if we look at the categories of the cables, we have the category 1. These are categories 2, 3, 4, 5. So we'll be mostly interested in this category 5, 6, and 7. So these categories, category 5, data rate can go up to 100 megabit per second, and it's used, of course, for LANs. The 6, we can go up to 200, and the 7 actually can go up to 10 gigabit per second. Okay, it's used also in LANs. So we'll study these in lab in more detail, and we'll do some terminations of these cables. So we have Cat 5, 6E. We have also 5E, but nowadays these are the most common categories. 5 is no longer used because we always try to use 1 gigabit at least LAN. So Cat 7 can go up to 10 gigabit per second. This is a Cat 5 UTP cable. So U for unshielded and TP twisted pair. So these are twisted pair and there is no shield. This is just plastic cover, you see. This is a twisted pair. They are color coded. So green, striped green, brown, striped brown, blue, striped blue, and orange, white with orange stripe. So you have always the pair, which is the color, and it's another cable is white with that color stripe. So here is brown and it's white with brown stripe. Okay, it's blue, is white with a blue stripe. So you know it's pair. Okay, so if you connect this side, you know the other side how you connect, because if they are not coded, you'll not know how to correctly connect them. Now we have the Cat6. You see, Cat6 can do a higher bit rates, as we said. So how you do higher bit rates? Actually, these twists are more, and there is, look, this plastic separator. This is a plastic like a cross. So you house each pair in these one of these sections, and there is this. You can use it as a ground. So this is Cat6. This is copper, of course. Again, the colors are same. So this is blue. This is white with blue stripe. This is brown with blue brown stripe, and so on. And the size is almost same. So if you measure this is almost same for Cat6 and Cat5. So they are nearly. This is unshielded twisted pair, UTP, no shields. We have the Cat7. You see the Cat7, this is a twisted pair, again same colors, and this is a shield, a foil, aluminium foil, okay? And there is another shield that shields the whole pairs. So with Cat7, you have the shield that shields the individual pair, and the other shield that shields them all together. So to connect these cables, we need connectors. So we have actually UTP connectors, we have STP connectors, and we have Cat7 connectors. They are almost same. We have, because we have 4 pairs and we have 8 wires, so we'll have 8 connectors. So this is the female jack, the RJ45 we call it, and this is the male connector. So you connect the terminal of the cable. When you cut the cable at the end, you have to enter them in this connector so that you connect with a device. So this will be available on a switch, on a computer, on a router, whatever device. So to connect your cable, you have to terminate it with this connector, and you have to do it properly. We have different configurations that will show you how to do them in the lab when we study when we start the lab. So as you know, we have limits on data rates, and that the length that the cable can go changes with frequency, because as the frequency increases, the attenuation increases also. So if you see these cables, this is the gauge of the cable, sorry. Gauge means size. So gauge 18 is, you see, this is gauge 26. So when the number goes higher, the thickness is less, so diameter is less. So gauge 18 is the thickest in this case. So gauge 18, of course, will give you less attenuation at a specific. So let's say at 100 kilohertz, gauge 18 gives you 2 dB per kilometer. So when you go 1 kilometer, nearly the signal will attenuate by 2 dBs. But gauge 26 will give you nearly 12 dB attenuation. This attenuation, how you handle this attenuation? So if you want to go to, say, 10 kilometers, the attenuation would be very high, and the signal will not go to the other side because it will be totally diminished. So how we increase the signal strength? Of course, we need repeaters. So if you have a cable that's very long, a long cable normally can go up to 100 meter. So 100 meter. So if you have a length of 200 meters, then you need to put some repeater in between, so that this is a repeater, so that the signal can reach the other side. Because the signal attenuates when you go from the sender to the end. There is attenuation. This attenuation at some point would be very high, that you cannot recover the original signal. You cannot distinguish it from noise. Therefore, we need repeaters at certain distances. So if you have 1 kilometer, you need, for example, 9 repeaters to get to. And this may be not practical in some settings. So we need to consider different technologies and different transmission media when you design your network. We have the other type, which is called coaxial cable. Coaxial cables were common in the earlier days, but nowadays they are not that much used. So in coaxial cable, this is like the TV antenna cable that you use at home. This is the copper. This is cover plastic insulator. This is another shield, which is mostly copper and can be aluminum. It's like a shield, like braid or. And this is another plastic cover insulator to protect the cable. This is a coaxial cable. We have actually 2 categories: 75 ohm used in TV antennas and some other, and we have 50 ohm which are used in like satellite communication and in also network. We use the 50 ohm. You studied transmission lines, so this is you see the impedance of the transmission line. Okay, to terminate this, you need terminators. You see, when you connect your cable to the satellite, you need to terminate it. So you need terminators. We have, this is the terminator that was used with this cable. So at the end, you terminate it, you connect it here, so that you connect this to the devices. This is called BNC terminator or connector. And we have the N types that are used for bigger cables with less attenuation. This is the N type. This was used for Ethernet in the olden days. In say 2000, we were using these cables and connectors. They were actually used in a bus topology, not a star topology like nowadays. So we needed T connectors as well. I think I have shown you before the connectors. We have 2 main categories. You don't need to remember these names. You don't use them anymore that much. But just in communication, we use these cables. So we have the 50 ohm thin Ethernet, which is called RG58, and RG11 is called thin Ethernet. Thin and thick, they differ. The cable here is different in size and thickness. Okay, here. So this is the BNC connector. This is the cable. When you terminate, you connect it to a BNC cable. If you have a new device, you want to introduce it, you need to cut the cable. So if example, this is a cable TV. It runs through the city. So if a new subscriber is to be added, you cut the cable here, add this BNC connector, okay? BNC T. So this is T connector. You do the both sides, and then you have this one. Now you can connect the other subscriber here with this side. Okay, and you do both sides. If you want, you reach the end of the cable, there is no devices. You have to terminate it with this terminator, 50 ohm terminator. Why we need terminators? You studied this also. Why we need them? We said this is a transmission line, right? So if you send a signal, and if this side is open, what happens? What happens if this is not terminated? This is 50 ohm. This is the end is infinite because it's open circuit. So what happens?
تعداد اشاره که میکنه نه؟
You studied that, I think. Of course you did. Open end transmission line. What happens?
Reflection did you say?
Total reflection will happen. So the reflection is, of course, will create much disturbance on the line. So the signal will. So if you don't terminate it properly, when you terminate it properly, we have to match the impedance of the line. So if the line is 50 ohm, the terminator also should be 50 ohm, so that no reflections can happen. When the signal gets here, it's absorbed, and there is no reflection. And this is impedance matching. You need to do that. So we used to use these in olden days, these types of connectors, but nowadays, as you know, they are not no longer used. They are used they're still cable TVs, they're still they are used actually at the there are cases that we use them, I guess, still. The advantage of coaxial cable is that they can go for longer distances. Their attenuation is less. So if you say, for example, they can go up to 1 kilometer without repeaters, 500 meters. We'll study these standards later in the Ethernet. They were used to carry voice signals and TV signals. There's still attenuation in coaxial cable. So, of course, again, if the cable is thinner, you see, the attenuation is higher. If the cable is thick, why we notice this? Why? It's easy. This is a cable. So if this is thick, the attenuation would be low. Why? Who can answer the question? This is copper. It has got.
So the current exerted is
yeah, that's
more data.
Yeah, but what's the relation here between the attenuation and the cross section of this cable? This is a copper, and it can exhibit resistance, of course, and resistance decreases when we increase cross section. So When you increase the cross section, the resistance decreases. The attenuation is related directly to the resistance. When the resistance is less, the attenuation is less. So, of course, when you have thicker cable, you have less attenuation because you have less resistance. Okay? So the next type is fiber cable. I think our meeting will end, so we'll be continuing at the beginning of next hour. Okay? And we'll be studying the fiber optic cables. Okay. Any questions until we finish?